I've got... Have you ever wondered how carbons, hydrogens, and oxygens bond together to create things like sugar, citric acid, and ascorbic acid? In class, we used magnets, and we showed the bonding by touching the magnets together. But what really happens at the microscopic level for carbon to bond with hydrogen, to bond with oxygen, to create such a complex compound like sugar? And the answer lies in the Lewis structure. The Lewis structure is a structure that shows electrons available for bonding. Here's what I mean. In the element hydrogen, for example, I have one proton in the center, and I have one electron on the first shell. I have 0 neutrons. This shell can hold up to 2. I could put another electron here and it would be full. But hydrogen only has 1 electron. Therefore, its street, its orbit, is not full. It is left wanting 1 more electron to make it full. So where do I get that electron? I can get that from other elements, other atoms. Other atoms can donate or give away an electron. Let's take into consideration the element carbon. Okay, so carbon's atomic number is 6, and its atomic mass is 12. We know its Bohr model looks like this. 6 protons, 6 neutrons, and 6 electrons. 2 on the first street, and 4 on the second street. Now, do you remember how many the second street can hold? Let's see, the first street can hold up to 2. The second level can hold up to 8. And the third level, which carbon doesn't have, can hold up to 18. So it only goes up to the second level, and carbon has only 4. How many does it want? It wants 8. And it's going to want to seek that stability from another atom that has electrons to share. And there we have it. We have 2 empty spots, ready to borrow electrons from someone else, like carbon and like hydrogen. So carbon, oxygen, and hydrogen are often found bonding together because they want a completed outer level. A completer outer level in this case would mean 8, and oxygen only has 6. So to make a stable element, I must borrow or share electrons. So what is the Lewis structure, and how do I represent it? The Lewis structure for hydrogen looks like this. You first draw the symbol, hydrogen, and then you draw how many electrons it had on its outer street. In the case of hydrogen, it only had 1 on its outermost street. In the case of carbon, it had 4 in the outermost street, so I draw the symbol, and I draw 4 surrounding electrons like that. And in the case of oxygen, It had
It had
6 in its outermost street. These are called Lewis structures. A Lewis structure just shows the electrons that are available for bonding. And that's it. Not all the electrons, but only the ones available for bonding, or the outermost street, the outer electrons. So let's work an example from our Lesson 3 worksheets. This is a little clip of one of the boxes you need to complete, and this clip is of neon. This clip is of neon. So I'm going to write, oops, Mrs. Mott knows better. I'm going to write, first, its atomic name, neon. The element neon is in the noble gas family in the far right hand column. Okay, neon has an atomic number of 10 and an atomic mass of 20. So I have filled out the little card there for neon. Okay, so in the previous lessons you learned that the top number tells me the number of protons and electrons. And you also learned from previous videos that I take the mass minus the atomic number, 20 minus 10, to get neutrons. In this case, neon has 10 for all 3 numbers. Now I must draw its Bohr model. Inside the nucleus, I can have protons and electrons only. So I am going to have 10 protons and 10 neutrons. Did I say electrons? I meant neutrons. That is in the center, the dense nucleus. On the first street, I can hold up to 2 electrons. And on the second street, I will need 8 more. And good, lucky for me, the second street does hold 8. Now remember, I can represent electrons by using little dots or dashes, meaning negative, or I can draw E's here. Any of those are fine. I like the simplicity of dots because it's a little bit cleaner for me. Lastly, the Lewis structure is the outermost electrons only, and neon is very stable with a complete outer street. Therefore, its Lewis structure looks like this. The outer layer has 8 outer electrons, and that is my Lewis structure. So let's look at how an element uses its Lewis structure, or its outermost electrons, to bond with other things. In this case, it's water. Do you remember that oxygen had an outer street that had 6 electrons on it? 1, 2, 3, 4, 5, 6. And how many does oxygen want, or any want, on that outermost street? The answer is 8, and it only has 6. Luckily, there is an element that can help, because hydrogen has only 1 electron on its outer street. What happens here is that hydrogens get close enough to the oxygen atom to share its 1 electron. In this case, I need 2 hydrogens to share with oxygen to create a stable outer shell. Now hydrogen is stable. It has a complete outer shell of 2. Remember, it only had 1 street. And oxygen's stable because it has a complete outer shell of 8. Therefore, oxygens and hydrogens often bond together like this to create a molecule we know as water. This atomic model can also be represented by its chemical formula, H2O. And we know it's bonded well together, and it's an essential compound molecule for life.